My name's Alex Irvine. I'm a first-year PhD student at the MRC Cognition and Brain Sciences unit, and I'm here to talk to you about my experience building an app for a large cohort developmental study using the Unity engine. So I'll just give you a summary of my talk. So first I'll introduce the Resilience in Education and Development project, which is what I'm working on as part of a broader team for my PhD. Then I'll introduce the Unity engine, how it works, what I think or thought were some of the strengths for the particular application that I used it for, and also some of the drawbacks. And then if I have time at the end, then I'll just show you a couple of measures from the app that we made. Okay, so resilience in education and development. So we know that environment and socioeconomic status are important for child's development, and that being low on socioeconomic status is associated with negative outcomes later on in life on the group level. However, in order to properly characterize these effects, we need to have high power studies with lots of participants, because you're talking about an effect like, for instance, socioeconomic groups within a large number of people. However, a lot of the high-powered studies in the field tend to only characterize SES on a single dimension, like income, when it's actually a multifactorial thing. So it might not just be just income that they use. They could use stuff like house price or other cultural measures. So if they do characterize SES dimensions quite well, they tend to have simplistic cognitive measures. So things like the brief questionnaire, which is when you're asking caregivers or teachers about cognitive skills of a child without actually directly assessing the cognitive skills of a child. Or if they do use an IQ scale, a cognitive measure, they might just use one IQ scale, like the Cattell fluid reasoning kind of test. And so we kind of set out to create a sensitive but scalable study. And so this means that we have enough richness in our measures to get at the kind of multi-dimensional aspects of these things, but it could also scale to test lots and lots of subjects. So we decided to go for a sample size of 1,000 children, and to just maximize the number of people that we had working on the project, we decided to do it in whole classroom at a time. And it needed to be, because of this, to some degree self-administrable by the children, so you could just hand an app to them and then they would complete all of the measures that we were giving them. And so yeah, this kind of led us on to wanting to create an app. And in creating an app, there's some considerations that we have when we wanted to choose the tools that we use to do this. So we're a small development team. So Giacomo Bignardi is the other PhD student on this project, and there's a postdoc called Edwin Daumeier, and importantly, and me. No, I'm not the important thing. The important thing is that we're all researchers, so we're not software developers. We do have, all of us have individual programming in some kind of programming experience, but we don't come from a games development background, and so building an app might be a challenge for us. And also we needed a rapid development tool, because I started my PhD, in fact we all started in September, and we had the plan of beginning to collect our data 6 months after the project started. So this isn't a great amount of time if we want to create something that has lots of different measures. And so we explored our options. And so one option, because we already had 30 iPads, we're kind of restricted to developing in the Apple environment. And so one option is Apple's own development tools, which is Xcode, and these other tools that work within Xcode called SpriteKit and Swift. However, this only enables us to test on iOS devices, which is initially a problem, but if we wanted to go with this kind of scalability concept and have other researchers take it into schools for us, they'd need to spend lots of money investing in iPads. So it might be nice to push to something like Android. And so we thought, well, we could do a browser-based app. However, iPad browsers are not ideal for many reasons. One of them being is we don't really have great access to permanent internal storage. Stuff is stored in the cache, and if the iPad crashes, we lose that data. We won't necessarily have an internet connection all the time. And we also don't have direct access to the hardware of the device because it's limited from the browser for various reasons. And so for these reasons, we decided to use Unity. So just to give you an introduction to Unity, Unity is a video games development engine, and you might think that's a bit strange that we're using a video games engine to design behavioral research tools. However, I think it caters to this kind of intersect between video game makers and behavioral scientists, and there's a few things in common that we both might want to prioritize. So for instance, both groups want good timing. So for game developers, this is frames per second. You kind of want to maximize the frame speed so things look smooth. For behavioral researchers, we want things to be presented at the time we intend for them to be presented, especially if we're gathering reaction time data to those objects. They both need to have good reliability. If you're designing video games, you need people to rely upon them, because otherwise you're going to lose your customer base. For us, it's more about not losing data, which obviously is a very important resource. Unity caters to this need for good networking and data transfer. Now with the gaming industry moving more to an online model, that's very important. And for us, we want to get our data that we've collected onto a server or onto a safe place in a computer as fast as possible, so it can be analyzed. And we also both have this common interest in scalability, which I'll be mentioning a few times more. And so you need your video game to be able to reach as many people as possible if you want it to be successful. And same if you're doing a large research project, you want your app to be able to just instantly scale to as many people as you'd like to collect data from. And one good thing another thing is it has to be easy to use, because not all video games developers are software programmers, and not all behavioral scientists have good programming experience. So it's definitely a plus to have a very accessible platform. And one big benefit, especially for scalability, is Unity allows you to push to over 25 different platforms. So once we've made our app, we can, within the push of a button, and obviously downloading some different libraries, maybe not that simple, but you can, in theory, just push that same project onto multiple platforms. So this includes things like iOS and Android, which we were interested in, but also stuff like WebGL, which allows you to host your app online relatively easily, although you still have to deal with the back end of things. But I'll talk about that later. So this is Unity. So Unity has a graphical user interface, which I found very helpful, because it allows you to initially build elements of your task within a kind of visual canvas. And this is great for debugging. So once you design the logic of your game, you can just press play and you can see what that's doing to the elements of your game without having to go to your script, compile, look at it, go change a variable. So it enables for kind of rapid development of things. You can drag and drop images and audio straight onto the scene, and then they're in your app. So you don't have to go into scripts and like put long file paths to the things that you want to include, although you can do that if you really want to. It still doesn't restrict you in that. If you want to like mechanistically load things in, you can. And you can preview at any time. So you press that, I don't know if you can see it there, the little play button, and then you can see what your task is going to be doing. And so each of these arrangements is called a scene. You can call scenes from each other, and you can also call them from scripts, so you can kind of change the configuration on the fly. But this fundamentally allows you to create order in your task, so you start loading new scenes in one at a time. And scenes can also act as templates, so you can make like a questionnaire template as a scene, and then you can have all of your questions and your answers in text, and it's loaded in, so you don't have to make one scene for every individual question. So that's also quite handy. So within a scene, everything is a game object, and a game object is just kind of like a blank thing. And in order, so everything in a scene is an object, and in order to make them look like things, you need to use components which go on your game object, and this is what differentiates between like an image or an audio source or other things that you can have. So here you have a game object which is called prefab dot. So it's one of these little dots that you can see kind of faintly on the screen, and it has two components on it. So the first one is the transform component, which tells you where your dot is in the scene, and the other one is the renderer, which renders the dot itself. And all of these can be accessed from your script. So you can kind of manipulate all of these things independently once you've built them. This leads nicely onto scripting. So Unity is controlled through C#, which I found really scary because C# isn't the most intuitive language if you're used to things like Python and MATLAB and other scientific programming languages. However, it uses Unity's custom library of commands. So you're not having to learn like Microsoft's .NET framework and complicated stuff like that. And it's very, very well documented, which is so helpful. So our development team, none of us have worked in C# before. From encountering it to 6 months later having an app, we were able to understand all of the logic that was needed to create the game. So that documentation was helpful. And another helpful feature is once you've scripted your experiment, you can assign things as public variables, which immediately makes them available in your editor. So if you want to change the number of trials or change any kind of components of like the task, sorry, I don't know, like the speed of it of each trial, you can without having to go into your script and change stuff. Yeah, it also had great integration with third-party tools. So you have software development kits and toolboxes for different purposes. This one's an out-of-the-box VR toolkit, which if you want to do kind of like VR research, which is becoming popular for behavioral scientists, you can relatively easily. Like you still have to fiddle around with a few things. And there's also stuff like Google Firebase, which I found very, very helpful. So this can manage part of the back end of your app. It allows for real-time data storage. And you can also manage participants with this. It's not as simple as like some of the other software out there, like Gorilla. Like it's way more hands-on. And the participant management thing has real good capability because you can push an app to your users' devices, and then you can alter the things that they're seeing when they go to that app each time, dependent on past performance, without them having to update their app again. And it also is very useful for piloting. So even though we are collecting data on iPads, I had this random dot kinematogram game, and we didn't know what kids were going to do because we hadn't really done any research with it. So in order to like get the variables at the right levels, we just hosted everything on Firebase, sent the link to people at work to test on their kids, and then we could set those variables at the level that we needed. It also has good version control integration. So we use GitHub to collaborate. You might want to change that depending on your feelings about Microsoft, which allowed us to very easily track and discuss any changes that we were making to our app, and we could also roll things back if there are any problems. And it means that once we finish this project, if we want to make our app open source, so other researchers or educational professionals want to use it, we can do that in the press of a button. Although I think I'd probably go and change some of our source code because it's a bit messy. Yeah, and I said I'd talk about drawbacks. So there is some programming involved, which is a drawback. So C#, as I said, isn't necessarily intuitive. However, I can't stress how good the documentation is for Unity. There's still problems, but there's problems with many software at this kind of level. Unity answers and Stack Exchange are great because it's such a widely adopted tool that most problems that you'll encounter will have had many other people encountering the same problem. So you can really use it as a community resource. There is a solution to this. It's not an ideal solution. You can use a visual scripting visual scripting plugin like Bolt. I don't use it, so I'm not exactly entirely sure how this thing works. But basically you have different modules and you can introduce kind of feedback loops, and all of the logic of your game is controlled visually without you having to touch script. But you can also then go back and like edit things in the script. So you can dictate your exposure to scripting, so you don't have to know it all. Another one is it's proprietary. You may have to pay if you're an organization. However, individual licenses are free, so if you're doing an individual project, then that's great. But it's proprietary, but the benefit that you get for paying for licenses is that it has great support, and when something goes wrong, you can come back and say like to the Unity to support, and they are more likely to fix stuff. Yeah, so that's pretty much it. And then I kind of wanted to introduce the app a bit. So we have lots of different tasks. I'm not going to go through them all. So we have some questionnaires on mental health, home environment, affluence, which is another kind of one of our measures of SES, attitude to school, technology use, and lots of others. We had some cognitive measures, so short-term memory and visual-term memory span tasks, some executive function measures, perceptual decision-making, which was the dot kinematogram stuff, a phonological awareness task, number sense task, and a fluid IQ task, which is similar to the Cattell, and also some outcome measures, so just a reading comprehension test and a maths test. Yeah, so here's an example of one of the games we built. This is a phonological awareness task where it presents you with the top item, which is the target item, and when that picture comes up, it says rocket, and it asks you if rocket rhymes with pocket or chipmunk, and the rhymes get progressively more difficult, and we don't know if it's going to measure phonological awareness, but we're also giving some standardized tests at the same time, so we can go back and see how well that relates to it. And this is the perceptual decision-making task. So there's a little snowman, and we characterized the kinematogram as a cloud of snow, and the kid has to basically drag the snowman in the direction that they think the snow is going, but that is kind of ambiguous and changes over time. And then we see if their y-axis of their response correlates with the current weight of evidence. And then we have a cancellation task, which is very loved by the kids because the cats meow when you press them. So you basically have to look for all of the cats, press them, and ignore all of the dogs. And this measures kind of search organization. Yeah, so that's pretty much it. I'd like to thank the team that I work with, specifically my supervisor, who's amazing, Duncan, also the lab members and the funding bodies who we wouldn't be able to do this without. Yeah, and that's the end. Also, follow me on Twitter. This is a shameless plug, but I will be releasing some in-depth blog posts on how to build a simple task in Unity. So if you're interested in doing that, then follow me. Cool.